Um, Solving the exponential equations with the relating bases method thing.
Okay.
I don't know what I'm doing.
Okay, that's no problem. We'll talk through it. Can you give a
Okay,
specific problem we'll talk through?
sure. So this one is the square root of 3 equals 27x, well, to the power of x. Sorry.
27 to the power of x, like this.
Yeah.
Okay, good. This one here feels strange right off the get-go?
Yes. So
Okay.
it's like the last 4 on the homework. I just am so confused. I don't know how to do them.
I feel weird on that one. So let's start to focus because what I like, I was watching another mathematician talk about how to kind of teach how he teaches, and it's always just like we have a human reaction, like that has to always be acknowledged as the first step, as we say like, whoa, I have no idea what's going on here, and so we do so. All right, deep breath. Then we come back and go, okay, no problem. Like, what do we have as something we can start with? So, what's something here that stands out to you? Some pattern.
Some pattern that 27 is a multiple of 3.
27 is a multiple of 3. That's brilliant. So 3 and 27 have this connection. Talk to me, how do you go from 3 to 27?
Well, 3 times 9 is 27.
3 times 9 is a good way to do that one. Let's put that one over here as a parking lot idea. So we could say 27 is 3 times 9.
Okay.
It'd be really nice if we only had 3s. Maybe that would make us see other problems, right? Or other patterns?
Yeah. So I know 3 cubed is 27.
Okay, 3 cubed. Let's think about each of those ones, how those might help us. Let's do, okay, so over here we have the square root of 3 equals 3 cubed to the x power. I'm just literally replacing just the 27 here, right?
Yeah.
Okay, so what does that let us do?
Well, they now have the same base, which is what we were looking for, I think. I don't know. I have no idea what I'm supposed to do now.
Okay, well, at least we got the 3s. That's a really good standpoint. What's the annoying part here? What looks annoying?
The x. I gotta solve for that.
It's like in that exponent, isn't it?
Yeah, it's up
Okay,
there.
that's the frustration. Now, we can approach this with logarithms. We talked about that in the lecture. You can choose to do that if you would like. It's actually the exact same thing. Let's think about how we could do it maybe both ways. If I had on the other side just 3 to a something as well, I think I would be able to ignore the base and jump just into the logic of the exponents, right?
Yeah.
But right now I don't have 3 to a power. Can you make that 3 or the square root of 3 into 3 to a power? Can we write that as an exponent?
Well, to want to do a square root, you square it.
Okay, we could get rid of the square root, but I think that's a little bit different from what we were trying to do. Actually, that would work. Let's try that way as well. Let's play around with that one. So let's okay, we want to square both sides. Let's play with that one. That's actually an interesting idea. Let's square both sides. On the left, that would get us what?
3.
On the right, that would get us
3 to the 5th x power.
to the what x power?
I don't know. I said 5th x, but I just added the
With a
exponent.
5?
Yeah.
Okay, you're trying to employ one of those shortcuts there, right?
Yeah.
Okay, I'm good with shortcuts, but make sure that we're not forgetting why those shortcuts work. What does it mean to have a power to a power?
Power to a power. Well, you do something that many times.
Okay, so in this situation, let's read it from inside to outside. How many 3s do we have?
3.
3 3s. And then I'm going to do all that x more times.
Okay.
So what would that be? Like if x was 2, that would be how many total?
5.
I think it'd be 2
Or
groups
no.
of 3, wouldn't it?
2 groups of 3?
Yeah.
Yes.
Okay.
This is true.
So what are you doing between the 2 groups of 3? Like how many would that be total?
6.
What's the operation you're doing there?
Multiplication.
You're multiplying. What we can read this entire thing off as a story is says that I have 3 3s, and then I have x groups of 3. So that would be x groups of 3, or x times 3, or 3 groups of x. Either way you want to like mix and match that in your brain. But that would be x groups of 3 would be x times 3. Also notice that's what I said in the language. I said I think we're going to repeat that x times. Like our language actually supports the math. It's x times of the 3.
Yeah.
And then we would put 2 times of the x times of the 3.
Yes.
So 2 times of the x times of the 3.
It's a lot of exponents.
That's a lot of exponents, but we could simplify it.
Okay. So 3 to the 6x power.
Okay, good. Very nice. What that essentially means is that you have 3 times of 2 times, or 2 times of 3 times of 6. Like we've got nothing more than 3 groups of 2 groups of x, or 6 groups of x, or x groups of 6, whatever you want to say, that we've got repeated amounts. That's going to be our multiplication. So on the left-hand side, this is now 3 to what power?
The first power?
First power. There's only one 3 over there. And on the right-hand side, we've got that it has to be the same as 3 to the 6x. So 6x has to be the same thing as
1.
1. Like if they're the same thing on both sides, they're the same thing on both sides. What does that mean x has to be?
1/6.
X has to be 1/6. Very nice. So a couple ways that we could do this one a little bit faster. First, let's check our work. Does this actually make sense? Square root of 3 equals 27 to the 1/6 power. Now, do you remember what 1/6 exponents means?
No.
Okay, 1/6 exponents, anytime you have a fraction, that's the same thing as a root. So, for example, square root of 3 could be written as 3 to the 1/2. Remember that?
Yes.
Okay, same thing we have over here. So this is actually a 6th root of 27. And I'm a little worried. I don't know if that looks like the thing is over here. Let's try it out. We could do 27 and factor tree that one out. That'd be 3 and 3 and 3.
Mm-hmm.
I don't need 6 of them. That's a little annoying.
Right.
But I guess the logic could stand that if I went one more layer, that would be root 3, and root 3 would multiply up to 3, right?
Yeah.
This one here would be root 3 and root 3.
Mm-hmm.
And this one here would be root 3 and root 3. And I guess that would be 6 root 3's. And I could pull one of those out as the representative, and that would sure enough be root 3 equals root 3.
Okay.
Okay, that's a little bit tricky. Like, you kind of got to know what you're searching for in that one. Another way of thinking about it is we could write this in terms of fractional exponents. We could write 27 as 3 cubed to the 1/6 power. And then just like you did over here, that's just meaning that I have to multiply it. So 3 times 1/6 would be 3 to the 1/2. And lo and behold, that is root 3. So there's a lot of different ways to get there.
Oh, gotcha. Okay.